Welcome to the Explainer. Today we are tackling one of the most crucial skills for anyone working with data: how to design databases the right way. Clean, professional, and built to last. Let's get right into it.
So let's dive right in with a problem that I promise you trips up so many developers and data engineers early in their careers. It's a situation that looks simple on the surface but can quickly turn into an absolute nightmare if you don't get it right from the start.
Just look at this table. This is a classic example of what not to do. You've got customer names repeated over and over. You've got multiple products just crammed into one cell. The whole structure is basically impossible to scale or get any real insights from. It's a total data nightmare. So the big question is, how do we fix this mess? And maybe more importantly, how do we design our systems so this kind of chaos just never happens in the first place? That's the core dilemma we're going to solve today.
I mean, the issues here are huge. All this repeating data, we call that redundancy. It's not just wasting space, it's a recipe for disaster when you need to update something. Trying to ask a simple question like which orders had a specific product becomes a ridiculously complicated task. And forget about growth. As your application gets bigger, this table will just grind to a halt.
The real solution here isn't about patching things up. It's about a completely different way of thinking. It all starts with creating a blueprint for our data. And in the world of databases, that blueprint has a name. It's called an entity relationship model. An ER model forces you to step back and think about your data structure before you even dream of writing code. It's a visual map that helps you organize everything logically, preventing the exact kind of mess we just saw.
Okay, so the very first thing you do is figure out your main things, your core objects. We call these entities. So for an online store, an entity would be a customer, a product, maybe an order. They're the main nouns in our data story.
All right, once you've got your entities, you need to describe them, right? And those descriptions, those properties, are called attributes. So for our customer entity, attributes would be stuff like their name and email. For a product, it'd be price and category. These are going to become the columns in our tables later on.
And this is where the magic really happens. This is what brings it all together. We define how these different entities connect to each other through what we call relationships. For instance, a customer places an order. That verb, that action, places, that's the relationship.
So if we take this thinking back to our messy online store, what are our entities? Well, it's pretty obvious, right? We've got customers, products, and orders. Each one has its own set of descriptive attributes. You can already see how we're breaking down that one giant messy table into a much more logical, organized structure.
Okay, so we've got our blueprint. Awesome. But is it the best blueprint? How do we make sure it's super efficient? Well, that's where this next crucial step comes in, the refinement process we call normalization.
So, what is normalization? Don't let the fancy name scare you. It's basically just a set of rules, like a checklist, that we use to clean up our design, get rid of that nasty redundancy, and make sure our data is rock solid. It's what turns a good design into a truly great one.
Now, what's really cool here is how these normal forms build on top of each other. First normal form, or 1NF, is super simple. No cramming lists into a single cell. Each cell gets one value. Easy enough. Then 2NF comes along and says all the data in a table has to relate to the entire main identifier, not just part of it. And finally, 3NF cleans things up even more, making sure data only depends on that main ID and not on some other random column. It's a logical process to make sure every single piece of data has one and only one perfect home. And honestly, most databases you'll ever build will be perfectly fine stopping right at 3NF.
So, after all that, after making our blueprint and running it through the normalization checklist, what do we end up with? What does that initial, messy table transform into?
We get this. Just look at it. A beautiful, clean, elegant set of tables that are all interconnected. See how we have separate tables for customers, orders, and products? They're all linked using special keys. And we even have this cool join table called order_item that connects a specific order to the specific products in it. Every piece of data now lives in exactly one logical place. No more mess. And this right here is the payoff. Why do we do all this work? Because this new model isn't just, neater. It's fundamentally better in every single way. It can grow with your business, it's incredibly fast and easy to query, it's a dream for data analytics, and it's ready to handle tons of transactions without even breaking a sweat. Okay, so this isn't just theory, right? This is stuff you're actually going to do. So let's talk about how you can put this into practice, because thankfully, you don't have to do it all by hand. There are some fantastic tools to help. Yeah, you are not expected to sketch this stuff out on a napkin anymore. There are some absolutely fantastic tools out there, from simple and free ones like Draw.io to more powerful code-based tools, all the way to professional-grade software like MySQL Workbench that integrates right into your database. These things make building ER diagrams so much easier. All right, you've seen the theory, you've seen the payoff, so now let's put you to the test with a challenge. And I'm not kidding. This is a super common question you'll see in data engineering or database developer interviews. So, take a second, pause if you need to, think about it just like we did with the store. What are the main nouns? The user? The restaurant? The menu item? What are their attributes? And most importantly, how do they all connect? A user places an order from a restaurant which contains menu items. See how the pieces start to click together?
Look, if there's only one thing you remember from all of this, let it be this quote. A good database always starts with a good ER model. Getting that blueprint right from the very beginning isn't just a nice to have. It's the absolute foundation for building anything powerful, scalable, and reliable with data.